This conference will now be recorded.
Good morning, all. I hope uh, I'm audible, right? I'm facing
Yes.
some bandwidth issue. So let me share my screen. Okay. I hope my screen is visible, right? Okay. So let's start our today's session. So yesterday we have discussed about Go Workspace and constants and pointers. So today we will go with data types, because data types again is an important topic, or it is also one of the pillar for any programming language you talk about. So we have seen the variable declaration and pointer declaration. Every time we are using some kind of data type when we are declaring, and same data when we declare the type of variable, then we have to store the value which is related to that particular data type. If we store any other type, it won't accept that. So today we will understand how data types works, and various data types are present. It may be numeric, float, string, and some of the list types. And then we will also see what are the default types are available, and when we have to go with the default or when we have to go with specific types. And then we will understand compile time and runtime. As I mentioned, this Go is a compiled language, and how it is generating the binary when we build the program itself. We will see that, and also we will do the cross compilation. That means we will change the OS, like that means in the environment variable we will set the different OS and will generate the particular executable for the Linux or Mac OS. And then we will understand what is strong typing and the static typing with the help of concatenation of the string with the integer. So how Go is providing that strong support and also the static typing. So first let us understand data type. Okay. So when I declare var a is int which is equal to 10. So now as per like previous discussion, I have just keep on mentioning we have a memory address. In that the memory address is labeled as a, and it is storing the value that is 10, but not exactly the 10 is getting stored on the machine, or the machine is not able to understand this 10 itself. So it will only understand zeros and ones, 0 or 1. So like there is a minimum information you can store on the system or machine, that is bit. So what is bit again? You can store either 0 or you can store 1 in a single position. So that is, we call it as a bit. So now if you group the bits, and that will become a byte. That means 8 bit is equal to 1 byte. So when you talk about 32-bit processor or a 64-bit processor, right, what it is actually doing is it is storing the 32-bit information on your system at the same time, or it is working with the 64-bit information while converting all your instruction into the machine level. So as I mentioned in the beginning of the session, we will be converting the high level code into the machine level code with the help of compiler interpreter. So what actually compiler is doing, it is converting all the information or instruction which I have provided in the high level language, that is something like this. It will convert everything into the zeros and ones. So zeros and ones is the machine understandable language. So the minimum bit you can store, that is 0 or 1. If you are dealing with 8-bit information, then it will considered as a 1 byte. For the 32-bit, again it will be converted into the 4 bytes. Again for 64-bit, it's just like multiplying of the 4 again, or it is maybe 2 power 0. This I will explain, but group of bit will be considered as a byte. So now let us take one simple example and we'll see how this information is converting into the binary when we execute the program itself. So even before that, let me explain. There are some specific types are available, and also there are default types are available. So let me go to this presentation. Okay. So generally, when you talk about data types in any languages, you will have these categories, that is numeric types, Boolean types, and character type. And again, group of character will be considered as a string. And then you have the composite type and complex type. Other than this, we have the pointers, function, interface, channels. So these also we will be considering as a types only in the Go language. So now we have numeric type again. So in the numeric type, we will be dividing in the like three different formats. That is to store the whole number, to store the float number, to store the unsigned integer. So one is in the numeric. If you talk about specifically about the integer, you will have two types. One is signed, another one is unsigned. So what is signed? Actually, it will consider the negative number including 0 and positive number. But what is unsigned? It will only deal with the 0 and the positive number. So that means you will be storing some negative value in the system as well. How that negative values are converting into binary in the when the program runs or when it compiles, during that time, how it is going to convert that. So there is some way it has to understand that okay, there is a sign bit is available. So that's why we have separate type for the signed integer as well. When it comes to float, you have the just you don't get the separate types here, but you will have the float 32, float 64. That means you can store the 32-bit information or you can store the 64-bit information. So even when you like see the integer type, right? Even for the signed and unsigned integer, how you are differentiating. So if you don't provide the u in the beginning, that means it is just a signed integer. If you see this u int 8, right, that is unsigned integer. So in even signed integer is divided again based on the number of bit information you are going to store it. That is int 8, int 16, 32, 64. So this we call it as a signed integer. So again we have the unsigned integer. Again it is divided based on the number of bit of information you are going to store it. So that is u int 16, 32, 64. And then you have the float type. So float again divided into float 32 and 64. So now we have the next type, that is I will show for the example how you can see the result when we use the specific types here. And then we have the Boolean type. So what is Boolean? So when you are dealing with some logics, right? If it is a true or false condition, or if it is giving the right or wrong condition, in those condition, if you want to build the logic, you will be using the Boolean type. So Boolean has only two values, that is either true or false. And then you have the character types. So character type is basically you have again two types here. One is byte and another one is rune. So that is a byte is an alias for the u int 8, and it will follow the ASCII character. So byte and rune, it will help in the like converting the character into the some specific binary code. So rune is basically an alias for int 32. Int 32, it follows the UTF code. So I will explain by going to this table, ASCII table and the UTF code. So basically, byte will support the less number of character. For example, you will be dealing with lot of characters in the program also. It is not only you will be only using the numeric value or float value. That is not the case. You will be using some of the string related data as well, or character related data as well. How those character will be interpreted and or compiled, and it will be converted into the binary. So as I mentioned, everything will be converted into the binary. How a compiler will understand that okay, this character should be this binary equivalent. How it is get to know that? Using the ASCII table and the Unicode character set. So basically byte will support the less number of character apart from what you have as an integer, but rune is support large or more number of characters. I will show the table. So for example, this is the ASCII table we have. For example, you are using the a character in your application to store some data. So this equivalent number is 65. Now this decimal value will be converted into the binary. That means currently if you can use any calculator, or even in the browser, if you go and search it for decimal to binary, you will get the equivalent. I will show how you can represent the 65 in the code using some of the format specifier. That time we will see what is the binary equivalent for this particular character. So, but when you see the ASCII table, okay, is this visible? Okay, so there are characters or some of the, like it may be alphabet characters, or it may be any special character you are using. So even the small case for the capital case, everything has its own number which is already provided in the ASCII table, so which is actually followed by the byte. So when you see this for A, right, for example, you will get this decimal equivalent, that is 65. So this will be decoded, or it will be used for the compilation process, and this 65 will be converted into the binary during the compilation or during the generation of this binary file. So how this actually the strings are converted into the binaries in the program execution. So now similar way for all the character, if you see A to Z, we have the equivalent some mapping values, and also for small letter also we have the values. But why we need Unicode character table when we have the ASCII table itself? Because here, if you can see, there are less number of special characters are available. But when you talk about different languages itself, it may be Spanish or French. If like there are keyboards are different, they will be use some different character altogether. Then they will be going with this kind of Unicode character set. So if you see this, there are again including ASCII table, that is whatever ASCII is supporting to us, that is also available here. And then but the numbering, how it is done with respect to the Unicode character, is little bit different. So now if you see, there are more characters are available here. So I think these are the characters which is supported in different languages. So those character is also supported in Unicode character table. So whenever you use or storing some data with respect to the string or integer or float, everything will be converted into the binary, which is in behind the scene, it is using these kind of tables to convert all your data into the binary format. So this is actually byte and rune. So rune is basically follows this Unicode character table, but byte is following the ASCII table, where it has a limited character. That's why when you are dealing with large number of character, you will go with this rune. So now once we understand this byte and rune, so it will only represent the single character. But you will be always providing the group of character. That means, for example, I want to store hello in my system, or hello world. So this is a group of character, it's not a single character here. So how it is going to understand that, it will treat it as a string here. So this is basically string, but string will use the rune and byte when it doing the conversion of each character. That means H equivalent, there is a decimal value, E equivalent, there is a decimal value. So again, those decimal value will be converted into the binary when it is compiled the program itself. So that is one type. Again, in the string, we don't see any separate type here, but it is just a sequence of character is often used to store the text. And now we have the composite types. So in the composite type, like apart from whatever the basic types we have discussed, we have this composite type. So in the composite type, we have four different types, that is array, slice, and map and struct. Why we need a composite? So again, as the name suggesting, it is a composite. That means it will group the collection of or it will give the list of numbers or list of string or list of float numbers. So when you want to store list of values, then you will be going with the composite type. Again, it will support same type of element or different type of element. We will discuss when it comes to array. So when we discuss about array and slice, we will go in detail how array and slice will work. But for now, to understand here, so array and slice is basically helps to collect the similar type of element. For example, you are dealing with integer type of element, you can only store the integer value. But if you are dealing with float type of element, then you can only able to store the float type of value. So you can't mix the integer and float in a single list. So that is not possible with respect to the array and slice. When you come to the map, it will have the key value storage. So that I will explain. And again, key should be unique here, and value can be anything. And then struct, it is used to store the different type of elements, whether it may be integer or float or a map type or any type you want to deal with. So different type of elements will be supported by this struct. So that is one of the type which is present in the composite type. Again, this part we will be discussing one by one in a separate session. So then we have the complex type. So in complex type, we have the 64 and 128 bit information. So this is a rarely used type, but when it is needed, basically when you are dealing with something called the real and imaginary numbers. So you will see this syntax, right? If you like follow some mathematics logic, right? There you will be seeing this real and imaginary part, where you will have the value for the real part, and also you have the imaginary part data as well. So now you, if you want to store these kind of data, then you will be using the complex type. So that is based on the bit of information you want to store. So 64 or 128, it will only support 64, 128. You can't store the 32 bit. So that is the complex type. I hope the types wise it is clear. I will show in demo, but these are the types are available in the Golang. And like this we will discuss later. Pointers we already discussed, like how to store the data for the pointers and all, or address we usually store. So function, interface and channel we will discuss later. And then I like keep on mentioning there are default types will be used, or you can mention the specific types as well. So what is default type or a specific type? When I should use the default types or specific type? So when you declare a variable, for example, you are using this kind of declaration, that is type inference or shorthand declaration, that is using this shorthand operator. These types will be this declaration will be considering this variable type as a default type, that is we are storing the integer. Now default type is integer for that. So what actually it is doing, Go is giving that support. If you even don't specify exact type which you want to use it, still I can still I can able to store the value according to the default type, whether for example it is having the integer. Now I can store, if it is a 32-bit processor, then I will use the 32-bit uh, uh, position, or 32-bit I can use to store this value, or I can use the 64-bit to store the value. It is based on the architecture of your system as well. So but if it currently my system is 64-bit, it still support the 64-bit value to store. So now if you again talk about bool and string, there is no default type, you will be fine even if you directly specify, or even you don't specify, still it will be considered as a bool and the string type. But for integer and other types, it will be treated as, for example, integer and float or complex type, it will be like using the some specific default type which is provided from the Golang itself. So during this shorthand declaration or the type inference variable type declaration. But if you are using the normal declaration where you will be specifying the specific type, for example, I want int 8 here, then you are telling this 10 will be stored in the 8 bit of information. How how much value this int 8 will support, so that I will explain, because there is some range for this particular int 8 data type. Only those values will get stored if you specify the int 8 type. But if you are exceeding that range, then you have to go with the int 16 instead of int 8. Or for example, for even in 16 has its own range, then if you are exceeding the range of when you are specifying the elements to store, then it will go with the 32. So this is how the memory allocation is done for the to store the data. So now let us see how like as I mentioned, 8-bit, 16-bit, 32-bit, right? So there is a specific range for that, how it is storing that. So, for example, as I mentioned, if we consider 1 bit of information, 1 bit of information, you can store 0 or 1, 0 or 1. So, if you are dealing with 2 bit of information, then you will be storing in the 2-bit combination. That is, you can able to store 0, 0, 0, 1, and then 1, 0, and then 1, 1. So what actually this binary equivalent, or the decimal equivalent for this binary, so it will be 0, and then it will be 1, and it is 2, it is 3. So how I am giving this calculation of or equivalent of this decimal value basically. So every bit will be considered as a 2 power 0, 2 power 1. So for example, I am specifying this 0, 0, right? This equivalent is basically 0 into 2 power 1 plus 0 into 2 power okay, this is 0, 2 power 0. So if you see this like this side of bit, right, it will start always from the 2 power 0, and you have to multiply with the digit, then again 2 power 1. So the next you will be considered, that is left to this bit, whatever it is there, it will always increment 1. So that is 2 power 1. If you have again one more bit, then you will be considering that as a 2 power 2. So this is how the calculation is done. So now if you do this calculation, right? Okay, let me. So anything multiplied by 0, it is 0 only. So if you take 0 and 1 combination, then 0 into 2 power 1 plus 0 into 2 power, okay, this is 1 into 2 power, that is 0. So now if you calculate this, so we will get this 1, right? 2 power 0, it is 1 only. 1 into 1, you will get the 1 value. And anyhow, it is multiplied by 0. This is 0 only. So how this will be calculated using this multiplication and the power concept here. So this is the equivalent. Again, if you do this for 1, 1, so both are 1, 1. So you will get 1 here from this, and you will get 2 from here, because 2 power 1 is 2. 2 into 1 is 2. So 2 plus 1 is 3. So that is the equivalent of this binary. So again, if you are dealing with 3-bit of information, then how a machine is storing that information using this 0, 0 combination, or like I'm telling what are the possible values can be stored by the machine. So here I can go with 0, 1, 0, okay, 0, 1, 1, and so on. Okay. So until how many values I can store, so that how you will be calculating basically using the formula, that is if you want to store n bit, so it may be 1 bit, 2 bit, 3 bit, you can replace it 0 to 2 power 2 power should be 4 minus 1. So that is n minus 1. This is the power. It is not like okay, let me do like this if it is confused. 2 power n, that is basically if you are dealing with 2 bits information, then how many possible values can be stored by the machine, that is 2 power 2, it is 4. But you are starting from the 0, that means you will be traveling till 3, that is 0 1 2 3. So now you want to extract 1 from here. So this is the common formula you will be seeing or using for calculating the range of values can be stored by this int 8 or 32. For example, I want to calculate it for 8. So 8-bit information. Then what are the possible values I can store? That is 2 power 8 minus 1. So maybe if you calculate this 2 power 8, it will come around, I guess, okay, let me calculate. 2 power 8. So it will have the value that is 256. You can do that later. So 2 power 8 will be giving the value that is 256. So you can store till 255 values, that is 0 to 255 values can be supported by the u int a. So now if you go to this int 8 type, then it will be little different because you will be storing the signed values as well, that is negative number as well. So then it will this particular value get divided, it will be range out from minus 127 to 127, I guess. Yeah, so there are specific, again I will show how when you define the particular or specific type, only these many values you can store in a memory. You can't, if you want to exceed, then you have to go with the higher type, that is instead of int 8 you have to go with the int 16 or int 32. So for again int 16, int 32 you can calculate later based on this logic whatever I have specified here. But when you talk about the signed integer, you have to use the another formula. So for the just unsigned integer, you will follow this 0 to 2 power n. It's not like the n minus 1, but 2 power n, and then you will be subtracting 1 from it. So whatever the value will be getting from the 2 power n, you will be subtracting that. But again, for the int 8 type or unsigned integer, you have the another formula, that is 2 power uh, n minus 1, that is in the power itself, and then you will be extracting 1 from here, and then 2 power n minus 1, again minus 1. But only difference is, so only the difference is this is the symbol you will be specifying when you want to store the negative value. So these all things I will be showing the demo. Like don't worry about that. But I need to explain how things are working when it is converting the some specific type of value into the binary value. So let me go to the demo. and I will try to explain. Any doubts here? At least whatever I have explained with respect to the bits and bytes, I hope that is clear. This is just how many bits you have and how many possible values you can store it. For example, if you have a 8-bit processor, then you can only store just 255 values in your system. You can't exceed the 255 or 256. Even 256 is not supported to store on your system if it is a 8-bit processor. That's why we will always go with a higher bit or 32 bit or 64 bit, so it will support like some large number. You can able to store it in the system. You can just compare it like that, so that you will understand why we need 32 bit 64 bit processor. But again, these are digital system concept, but for the explanation I just explained here. But even if you don't understand this all calculation, like don't worry about that, because we will always see in the program, you will directly understand that how it is doing the conversion. But everything will be converted into the binary values only. It will not directly store the 10 or hello world in a system. So if no doubts, then we go to this VS Code. And one more thing I have missed it. So basically, as I mentioned, you have default types, right? And then you have some specific types. So when you have to go with the default types, when you have to go with the specific type. If you are more concerned about the memory and performance related thing, then you have to use the specific type, because it will save your memory space. That means if you use the int 8 instead of int 16 to store 10 as a value in your system, that means it is storing the like it is only using the 8 bit of information to store the 10 value instead of 16 bit. That means another 8 bit will be saved during the execution of the program, so that will be used by some other process, or it is using the memory optimization there. So that is instead of 16 bit, their user is specified this is of type int 8, so let me go with the 8 bit only. So that is how the performance will be improved in terms of memory aspect. So that is one use case where you have to use the specific type. But if you are not concerned about the memory size and all, because you, anyway you will be buying a lot of like memory from the as an as an hardware component. So if you don't much concern about the memory size, then you will be using the default type. That means it can take in 32 or 64 bit, even if you want to store the same value, that is 10. So 10 will take 8 bit of information to store, or if you are just specifying that is a int type, then it is also go with the 32 bit or 64 bit of value. So that means you are storing, or you are saving some of the memory space while storing the data. So that is the only difference from the default type and the specific type. So now let me create this. Okay, so now let me create main.go here. Okay, so now provide package. Let me take the 10 to store this value, and let us see how with the 8-bit and if you just specify the int directly, it is taking the 32 of 64-bit based on the processor you are using. But if you are specifying the particular bit of information, then it will be going to take the like correctly the 8-bit or however or number of bit you are specifying the size for this particular value. So now let me print this directly, and I'm going to take another variable. I'm not directly providing the type here. So here let me keep it as for the type inference type, and then so currently when you want to see the binary equivalent for this number, you will have the format specifier, but how exactly compiler is converting that you can able to see in the .exe file when it is generated. But again, binary file you can't able to open it because everything is contains the zeros and ones value. You can't even understand what actually the binary file is contained. But for the understanding purpose, what we can do is in the program itself we can use some format specifier, and we can able to see what is the equivalent binary value for this number. So now for that, let me provide one function, and also so currently here I'm using the 8-bit type. That's why I need to provide how many bits you want to represent. Currently, if you just provide this directly, so I will execute this first and I will show and how you can modify the format specifier to see the number of bit information for this 10 or 20. So just let's okay, it is okay. So now main is giving this error. Basically, as I mentioned, whenever the new module gets created, you have to add this into the go.work file to maintain all the modules in the same workspace. So that's why it is giving this suggestion. Let me go to this quick fix, and then you will get this use this module in your workspace. When you click on this, it will just directly add it into the go.work file, and then this error will resolve. So let's wait for that. So currently day 3 is added, but yeah, let's wait for that to reflect here. Okay, so now the error is gone because you have added this particular day 3 folder inside the workspace. So now let me run this file and we'll see what is the equivalent for this 10 or 20. Let me specify like this. Okay, so now let me run the main.go file. Okay, sorry, this I have to provide printf. Okay, let me run this again. Okay, let me run this again. So now, okay, here let me provide this as a B to see output, and then after this let me provide one println statement. So we will discuss what this printf and println function later. Okay, still okay, I provided multiple statements here. So now, as you can see, for the 20, the decimal equivalent is 10100. And for the 10, the decimal or binary equivalent is 1010. How it is doing the calculation for the binary or decimal? So as I mentioned here uh, in the whiteboard, it will actually taking the power of 2 power 0 for the very first bit, and then when you go to this left side, right, you will get 2 power 1. So that means here it is 2 power 0 for the first bit, and then 2 power 1, and then if you go again 2 power 2, how many bits are there? For everything there will be a power of this 2, and every time there is a 0 1 2 get incremented at the power. So now even here also, if you see, this is a 2 power 0, and if you multiply with 0 you will get the 0 only, and then again this is the 2 power 1 position, and then if you multiply with 1 then you will get the 2 here, and then here we will get the 0 anyway. 0 is multiplied by anything, 0 only, and here this is 2 power 0, 2 power 1, 2 power 2, 2 power 3. So if you may do the 2 power 3 into 1, it will give the 8. So now 8 plus 2 is 10. So 10 equivalent binary is this value. So that is how it is calculating or converting this decimal into the binary. And again for the 20, it is also the same thing. So it will do the conversion accordingly. So now it is currently giving 4 bit of information and 5 bit of information. So why still 20 you can do it in 4 bit information directly, right? Why it is not able to do it in like or 4 bit, it is giving the 5 bit information? Because 4 bit is only support some range of number, it will not directly support the 20 to store it. So that's why it is giving using the another bit to store the particular value. So now if you want to see it in 64 or 32 bit, or based on the type you are specifying, then you have to mention one format here. That is, if you want to see the 8-bit information for the B, or like for this particular A value, then you have to mention 08B. And for example, here I'm not specifying any of the type here. It is by default taking the int type. That means it will take either 32 or 64-bit information. So let me provide the 64 here. So now if I run this, you will see the difference. So as you can see, for this A, still it is having the same like conversion, that is 10 to the 1010. But if you are specifying the int 8, right, then it will consider 8 bit of information to store, and then if there is no like remaining value which can consist of 1, then it will store all the values as 0. So now in the programming, the minimum data type will be start always from the 8-bit information. You can't store below that. So that's why always we are going to use the 8-bit for a particular range of value. So as I mentioned, int 8 will support. So let me take the uint. It will support only the 0 to 255 values. So as I mentioned, it is now uint type. So basically it will only support the 255 values till 0 to 0, 1, 2, 3 till 255 values you can store. If you provide 256, then you are getting this error. That means cannot use 256 as an uint variable, and this is usually saying overflows. That means it is out of the range for this particular type. If you want to store the 256, then you have to use that uint 16. Then it gets like the error resolved now, because 256 it is in the range of uint 6. So that's why it is still able to support. So still you can store the 255 in the 60 uint 16 as well. But what is the like more optimal or optimized method to store the 255? You can use the 8-bit, because it will only consume the 8-bit information from your memory instead of 16-bit. You can still save 8-bit of information for different purpose. So that is the basic need why you have to go with the specific type. If you are more concerned about the memory usage and the performance related thing, then you have to definitely consider this specific type instead of uh, the type inference type. That is, Go is assuming the type when you declare the variable. So if Go compiler don't want to assume anything, you have to explicitly provide the specific type for the memory and the performance related thing. Then you have to explicitly specify whenever you are declaring or providing some values. So even if you provide the shorthand declaration, still it is going to use the default type only. So let me give it a see here. So as you can see, if you hover over this particular variable, so let it load. Still loading. Okay. So now, as you can see, this variable which is of type int, when you don't specify, then it will take the default type, that is int. It will store 32-bit information or 64-bit information. So now let us see for the 255 what is the binary equivalent. Currently I have specified it as in the 8-bit information. So let us run this. So okay. So as you can see, for the 255 all the values are 1. So even you can do the, like you can use the calculator, or you can use some online like online there are number of tools are available to convert this decimal into the binary. So for the time constraint, I'm not going to explain everything for the conversion related, but I have just explained how conversion is happening. You can follow that. Even after the session, you can try out for any values here, and you can still able to get the equivalent binary values. So it will only store the zeros and one as an information at the end of the day. It will not store directly the 255 values inside the machine when it is running the program. I hope this is clear. I think it is too much again for the data types, but again, if you understand how data is storing in the machine, then you have to go through this. But everything is in the binary format only. So you will not see when it comes to the machine level language, you will not see 255 or 10 or 19. Those kind of value will not be understood by the machine. So everything will be converted. And so again, I will show the .exe file, but .exe file you can't directly open it. But in some OS, that is Linux, it is directly supported. Still it will not, you can't able to read what actually it is there in the binary file, because it is having some like machine level understanding code. So that's why, but I will explain how you can generate or build the binary file for this particular code. Any questions here, or anything is not understandable here in the explanation part?
Oh no, Preeti.
This is this is again some of the calculation. Just write out like when you get time and try to understand how the conversion is actually happening. But as I mentioned, for the example or demo, I will be taken directly like 10 will be stored in the A, right? But it is not actually happening. But every time I can't type the equivalent for this 10, that is binary equivalent for this 10. So you have to make sure that you understood that concept, everything when I provide here. So that will be in the binary format. But what actually machine is understanding, it is only bit of the information, that is 0 and or 1. So yeah. Okay, so if this is understood, let me go and explain some of the other data types. So let me take float, and I will remove this because again we are going with a specific type here. So let me use var. Let me provide some random name to it, and I will going to provide float. Let me provide float 64. How? So basically, when you are dealing with integer, you will be having the whole number only. That means you don't find any decimal values like this. So you will mostly deal with the whole number, that is including 0. But in the float, you will be seeing the decimal values. For example, 1, 2, 3, 4, 5. So this is how you can store the values inside the float. So again, you can't directly store the 123 into the float 64, because it will treat it as a whole number. And again, in the Go, there is no implicit conversion will be there. You have to explicitly tell what it actually done by the program. So that's why you have to like make sure that you are using the decimal point here. So again, if you use some decimal point here, you will get directly the error, because this integer is only supporting the whole number. It will not support any like decimal values. So that's why we are keeping things separate to store a particular type of values to the particular data type. So now how this for now we understood that when we have the decimal value, we can directly convert the decimal equivalent, that is the binary equivalent for this 255. We can directly able to see that. But for the float 64, it is little bit different, because it is going to follow the IEEE 754 format, that is the standard format which is available. But again, this will not directly tell how the conversion will happen, but this is the standard format we will be following when we will be doing the conversion of this float 64 into the zeros and ones. So I will show what is the equivalent for this float 64, that is 123.45, because we have this separate what position as well. Like after the decimal, we have this 45 as well. How it is doing? So it is using some exponential concept. So again, you don't need to much worry about how it is converting that 123.45 into the binary. But when you run the program, you will understand the equivalent of this binary. But what you need to know is it is directly following the IEEE 754, that is the standard format, which is for the float. So as we seen for this u int 8, right? So it is doing some calculation. Similar way, there is some formulas are available. This is like exponential level. So that's why I'm not explaining here everything. So, but it is following the IEEE format. So now let us see by printing the binary format, how it is doing that conversion. So now it is a 64-bit. Let me give it a 64-bit, and I will provide this as an if. But again, as I mentioned, whatever the data you are trying to store here, so everything get converted into the, okay, let me provide 0, because when nothing is there, you have to like provide the 0 in the bit position. So that is what I am telling. So to give an understanding here, or how the binary representation works in the machine. So that I am trying to explain here. So as you can see, there is some exponential value which is generated or provided from the IEEE standard, but this again will be understood directly by the co-compiler, and when it tries to run the program on the machine. But again, you don't need to worry about it is 8687021. It is again internally it will do the conversion for you when a compiler will like do the execution of the program. So again, not too much here, but this is how the conversion will happen from the high level language to the low level language, which is understood by the machine. So this is for the float, and then we have Boolean type, right? So let me provide B, which is of type bool. So now I can't store any integer value, float value. I can only store true or false value here. That is here. I can provide this true as a value. This is the syntax. You can't provide any mistake, or you should not do any mistake while providing the value, because it will only have the true or false value. It is by default will be following all the lowercase only. It will not allow for any uppercase while defining the true or false. So this is again from the Go syntax only. So even if you provide something like 123, it is not going to allow, because cannot use 123 as a bool value in variable declaration. That is already giving the suggestion. That means bool will only hold the value that is true or false. Only those values are allowed here. So you can only provide true here or false. How you can provide the false? So like this, it will only having all the small case letter. So now again, this will be helpful in the conditions logic, but again, you don't need to worry about the binary conversion here, how it is understanding. But again, for the Boolean, it has its separate conversion. But let me print out the value directly here. But whatever I have explained for the integer and other types, similar way for other types also, it is doing the conversion. Okay, I did not. So it is just printing the value which is present inside the Boolean. So let me use the another type, that is byte. Let me provide. So we have byte type, as I mentioned, it will support the ASCII character. So now if I provide the character, so when you want to provide the character, you will use the single quotes. When you want to declare the string, you will be using the double quotes. So now I am providing the A. So now let us see what is the equivalent value for this A. That is using the printf percentage D. So percentage D will give the decimal value or number which is related to this particular uh, variable, that or not variable, it is just a value we are assigning as a byte type. So A equivalent is 65, as I mentioned. So let us see whether we will get the decimal equivalent of this A is 65 or not. So even if you provide B here or any special character, for everything it has its own mapping of values. So even I have shown the table, right? Accordingly it is doing the calculation. For the B we have the 66. So byte is following the ASCII value, and also it is an alias for the uint 8. That means it will only store the 8-bit of information. If you convert this 66 then or any character equivalent value, then up to 256 value you can able to store it, because when you see the table, So the ASCII character which are present in the table, it will from the 0 to 255. So that's why it is an equivalent to the uint8. So uint8 also supports 0 to 255 decimal values. So that's why we are providing the alias for this byte as a uint8. So for the rune, let me. So rune is basically support all the ASCII character, and apart from ASCII character is also, it is going to support a different character from the different language. For example, if someone is working with some different language, that is Chinese or French or anything, so those character is also still supported in the Unicode character. So let us run this. So now you will get 66, and for this you will get 65. Okay. So when you are dealing with single character, then you will go with either byte or the rune type. So now how you can give the variable declaration for the string type. So for the string type, let me provide this example hello. So now let me print out. So currently it is not going to print out the or it will give some errors here, because string is a collection of character. It is not a single character. When you want to, as I mentioned, we have a composite type, right? Even list, array, or slice, or map, or struct, whatever it may be. So those are also collection of elements. So even string is also actually a collection of character. If you want to access each character and also the equivalent value, then you have to use the for loop. That means what is for loop, don't worry, but each character I want to access it individually. I want to get the equivalent of this particular H, E, and the L, L, O. So then what I need to do, I need to use the for loop to range over this particular string, and I will be getting the each character at this like particular time, and then I will be printing out the particular like decimal value, because you will not get the entire equivalent of L, or for this hello word you can't get directly the decimal equivalent, but you can get the individual character decimal equivalent. So now let me show that, but currently don't worry about this for loop and everything, but just we have the collection of character. I need to access each character from this string. How can I do that? Using the for loop, so that you can understand here. So I'm going to use the range keyword here. Let me range over it, and then I will use, so let me use the V here. So let us observe the output here, and we'll compare whether the equivalent whether it is correctly or not by comparing with the ASCII or this table. Let me provide some here.
Priti, we are not able to see your screen.
Okay, what I will do is, so let me provide session here. Oh, okay. One second. Oh. Can you able to see my screen now?
Yeah, Preeti, now.
Okay. So I don't know at what point of time you were not able to see the screen, but I hope I was trying to explain this string type. From there, you were not able to understand, or from where the screen got stuck.
Actually, from last 10 minutes onwards, we face this problem, Preeti.
From Okay, so which topic, like particular data type, when I talk about, from there you won't understand, or like,
Rune, from Rune onwards.
okay. So rune is basically it will have the ASCII character along with the other character, as I have shown the table, right, for the UTF table. So there are many characters available, not from the English character. It is also from the different languages. So that is the uh, like flexibility which is we will get from the rune. But both in the like whatever the character you are specifying, so that will be if it is available in the ASCII, both will be having the same decimal equivalent. But when we have the string, right, string will deal with the collection of character. So that means you can represent inside this double quotes and provide the string here. And a string is basically a collection of character. You can't directly access the each character. You have to use some other concept, that is basically for loop here. So what for loop is going to do, it will range over this particular string, and it will fetch each and every character, and it will give the decimal equivalent for this particular H, E, and L, L, O separately. So you will not get the decimal equivalent for the entire string, but instead of that, you have to make sure that you are converting each or you are seeing the decimal equivalent for the each character. So that's why I have used the for loop here. But again, don't worry about the syntax wise here, but let's focus on how the string will be or each character in the string will be converted, or we will get the decimal equivalent for this character. So now let me run it once again. Okay, so now if you see the particular value, right, I think somewhere here actually it is printing the 65. So let me provide println here, so that 104 will come in the next line, so that it will give more clarity. Because 65104, it's not the value for H here, but previously I have provided this printf statement for the rune. So for the A character, the equivalent decimal value is 65. That is what it is printing. And when you see the hello, for the hello string, right, so each character now we are getting the decimal equivalent. That is for the H we are having the 104, and E for 101, and others. So now let us see whether the value which are getting here or showing here, it is correct or not. So for the H we have the 104. So let me check it out in the ASCII table or UTF table, because still 104, it is within the range of 255 only. So let me check it out for the H. So if you can see right here, uh, Okay, so this is the H value, that is the small letter I have used. So for the H, we have the decimal equivalent, that is 104. Even for the E, 101. So if you see the E value here, that is 101 we are getting. So everything is followed using the ASCII table if it is a byte type, and by default for the string, you will be seeing this rune type. That is, I am getting the rune for each value, that is each character present in the string. So this is actually what it is doing when we provide the string. I hope this is clear. Any question here? But again, this is not actually storing in the machine, or it is not processed by the machine directly. You have to use the binary equivalent. So that is actually used by the machine. For now, to understand here, again, just I have provided the decimal equivalent. But this decimal will be internally converted into the binary when it is compiled. I hope this is clear. Are any questions here? You can hear me, right?
Yeah, Priya, it's a Preeti.
Okay. I hope the data types concept is clear. So most of the things I have discussed here. So even I have given the clarity how data will store in the machine. Any question in the today class? We will end the session because too much for today. Even I explained lot of the things. So try to go through the recording once again if you don't understand what is bit and byte. Because it is very important when it comes to memory management as well as the performance related things, because you are writing the code, right? If you specify to store the 10 value inside the memory, then if you use the int32, it doesn't make sense with respect to the memory optimization. But if you use the lower bit of information, that is int 8 or uint8, then it will make sense to like save some memory space during the performance related issues. So that's why I have explained in detail here. But yeah, if you don't understand anything here with respect to bit byte, what actually these formulas and all, so try to go through once again the recording and try to understand it. Or actually, yeah, I have the topics, that is compile time and run time. So I can show that. But yeah, I think this for today this is enough. um, and by Friday I will push all this code. You can try to practice whenever you get time. So because this I have to add some readme file here. So what we have done in the day one session, I will add theory content here itself, so that you can refer, and as well as you can try out examples here. If you don't understand anything there, so you can go through like part of recording, you can watch it and understand. So yeah, I hope this is clear. Again, if you have studied the digital system, right, you will understand easily all these things. But again, it's not again a complex task. You can just go through once again and try to understand it.
Yeah, okay.
So if any questions, maybe we can discuss tomorrow. But yeah,
Thank you, Preeti.
yeah, thank you. Okay, I will end the call. I think you guys can leave.